Okay, running through the answer key to Unit 2, Lesson 3. It says Noah's running a portion of a marathon at a constant speed of 6 miles per hour. So that 6 miles per hour means in 1 hour he's going 6 miles. And what we have to ask ourselves here is, what's our constant of proportionality? And going from left to right, we're multiplying by 6, which means that's our constant of proportionality. It means every time we go this way, we multiply by 6. So if I multiply half by 6, I get 3. 1 1/3 by 6, I get 8. Now I'm being given the miles that he traveled, and I want to know how long did it take him. So I'm going this way. That's dividing by 6 or multiplying by 1/6. 1.5 times 1/6, and I can use my calculator for this if I know how, is 1/4. Let's just on the side here remember how we do that. 1 1/2 divided by 6 or times 1/6 would be 1 1/2 is 1 times 2 is 2 plus 1 is 3/2 times 1/6, which is 3/, remember how we multiply fractions, we just go straight across, 3/12, which reduces to, simplifies to 1/4. If I do 9 divided by 6, or 9 times 1/6, I get 1.5, or 1.5. If I do 4.5 divided by 6, I get 3/4, or 0.75. And I don't mind if you answer in fraction or decimal there. Okay. Next question, complete the tables and interpret the constant of proportionality. So let's see, to go from here to here, from left to right, I need to know what I'm multiplying by, and to find that, I divide this way. And that would be 1 1,000th. So I'm multiplying by 1 1,000th, or 0.001. And if I multiply these numbers by 0.001, I'm going to have 0.25 or 0.250. I would have, so remember how I multiply by a decimal, or divide by 1,000. 12.0 divided by 1,000, I would move that decimal tenths, hundredths, thousandths places, would be 0.012. Now if I go in the other direction, going from here to here, I find that number by dividing 1,000 divided by 1 is 1,000. So to go from left to right, I'm going to multiply by 1,000. So I'd have 5,000 here. 20 times 1,000 is 20 with an extra 3 zeros, so 20,000. To do a decimal times 1,000, I'm going to take that decimal and move it 3 places, tens, hundreds, thousands, so 300. So now the question asks us, the constant of proportionality tells us what? The constant of proportionality in the first one tells us that, and we're going to be specific here in terms of this problem, to go from meters to kilometers, we multiply by 0.001. So again, to go from meters to kilometers, specific to this particular problem, we look at that constant of proportionality. It tells us to go from meters to kilometers. We're going to multiply by 0.001. Conversely, in the other question, the constant of proportionality, again, is the number we find in the row that has the 1. To go from kilometers to meters, we will multiply by 1,000. So again, the big takeaway here, looking at that, finding the constant of proportionality is always where the 1 is in the left-hand column. The value in the right-hand column at that point is our constant of proportionality. And it tells us something specific to a given situation. So we don't just say it's what we multiply by. It's what we multiply by to go from something to something, or how many something per whatever. The next question asks, in that same question, what is the relationship between the constants of proportionality? So we had 1 1,000th and we had 1,000, and our best math answer there is they are, our good math word here, reciprocals of each other. Okay. All right, question number 3. Jada and Lynn are comparing inches and feet. Jada says the constant of proportionality is 12. Lynn says it is 1/12. Do you agree with either of them? Explain your reasoning. Sure, so the difference here is one of them is going from feet to inches, and the other one is going from inches to feet. 1 foot has 12 inches. 12 inches in 1 foot. Our constant of proportionality here is 12, and here is 1/12. So yes, we can agree with both Jada and Lynn in this situation. We skipped question 4, and then we're down to question 5. Did we skip this one as well? We may have skipped this one as well. I'm going to skip it now. And down to question 6, which of these is not like the other? Explain what makes it different using ratios. And again, I'm going to make a table here, and I'm going to do length to width. What looks different? So these look the same, except that middle part looks different to me. The middle part has 1, 2, 3, 4 to 1, 2, 3, 4, 5, 6, 7, 8 for M. The middle part in L has 1, 2, 3 to 1, 2, 3, 4 units. That's for L. And N has 1, 2, 3, 4, 5, 6, 7, 8, 9 to, did I count that right? Let's see, to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that's for N. And if I divide those out, if I divide M, I get 2, 8 divided by 4. For L, I get 1.3 repeating, and for N, I also get 1.3 repeating. So the two that are the same would be L and N. The one that's different would be M. And is there anything else here? I think that is it. Yep, that's it. So that's the end of your lesson 4. Practice problems, check your answers, make sure you know what you're doing. We will have a quiz on Tuesday.